Morning students, hope you all are doing good. So we will continue with our chapter motion and the topic is uniform and non-uniform motion. So let us first look at the motion in a straight line. The motion of a body may take place in one dimension, that is in a straight line, and this is the simplest form of motion. It is also known as linear motion. This can be represented graphically by plotting a graph between the position of the body and the time taken by it. This is called position time graph as shown below. Now, the things to be noted down here is first, the distance measured to the right of the origin on the position axis is taken to be positive and the distance measured to the left of the origin is taken to be negative. As you deal with number line, the origin here is represented by 0. Second, the origin for position can be shifted to any point on the position axis based on the problem given to you. Third thing is the distance between 2 points on position axis is not affected due to the shift in the origin of the position axis. That is, the distance remain the same. Even if you change the origin, the distance will remain the same. Same graphical representation can be used to understand that how the displacement for a particular body can be negative, positive or 0. Let us move on further. We will discuss now what is uniform motion and non-uniform motion. So first, uniform motion. A particle is said to be in uniform motion if it moves in a straight line and covers equal distance in equal interval of time. Or in simplified manner, a particle body with constant speed is said to be in uniform motion. Now what is non-uniform motion? A particle or body is said to be in non-uniform motion if it covers unequal distance in equal intervals of time. Now to understand it in a better way, let us look at these examples and comparisons. Uniform motion. Suppose car A travels equal distances in equal intervals of time, so it is in uniform motion. And the example can be the movement of the hands of the clock. They move equal distances in equal interval of time. So this is uniform motion. Now for non-uniform motion, car B travels unequal distances in equal intervals of time, so it is said to be in non-uniform motion. Another example can be an athlete running in a race, because in practical life, in daily life, we can see that we cannot travel with constant speed for longer duration. There will be change in speed and we will be covering different distances in different intervals of time. So in practically in daily life we undergo non-uniform motion. Now the graphical representation of uniform and non-uniform motion is given below. These are the distance time graphs for uniform motion and non-uniform motion. The first graph shows that distance remains constant with time. And in the second graph, it is shown that equal distance is covered in equal intervals of time. Now for non-uniform motion, the third graph shows here unequal distance is covered in equal intervals of time or increasing non-uniform motion. As you can see, the graph is little bit curved. Now in fourth graph, unequal distance is covered in equal intervals of time because decreasing non-uniform motion. So this shows the decrease in the non-uniform motion. That is, the distance is decreasing. Distance being covered is decreasing with increase of time. So these are the four graphical representations of uniform and non-uniform motion. Now I hope my kids you understood what we discussed today. So here are some questions for you to be done as homework. Thank you.